Today I'm taking a look at the VEVOR hot air tool. Looks a lot like the hot air tools that we're all used to, except for this one is much beefier and larger. It does have a rubber grip right here, which has also got a castling on it, so if we want to, we can lay that guy down. We don't have to worry about it rolling away. It does say on there it's good for 120 volts, and it can pull 13 amps, so this guy can get very hot. Got a nice thick long cord on here. It says 14 aux, so that should be able to handle the 13 amps no problem. And on the bottom we got our on-off switch and our temperature adjustment. That adjustment does have numbers associated with it, and you can see the arrow right there, so that is pointing currently to a 1. And then we have a guide on top that'll tell you approximately what temperature you're going to get with the different tools. So it will vary depending on the tool that you use. Here we've got a seam roller. So it has a silicone head, so you don't have to worry about that melting. So what that'll do is whenever you melt that plastic, instead of having a little ridge in there, you can kind of smooth that guy out. So it does come with an extra heating element. So in the event that this one ever goes out, we actually have another one we can use to replace it. Very nice that they included that. And this does come with a couple of heads. So we do have instructions. It says this can get up to 600 degrees Celsius or 1,112 degrees Fahrenheit. And it actually gives us the dimensions of the nozzle in case you want to make your own or find something else. It says that runs at 78 decibels, which is a little on the loud side, but that is kind of what I expect out of a hot air gun. So here I've got a polyethylene wall outlet cover. And I'm going to use a thin nozzle. This does have a screw on here, so you can tighten that down to lock it to the nozzle. It's really a good idea to actually do that, but for right now I'm just going to use a friction fit. The reason you would want to lock that down just because you don't want to have this thing heated all the way up and then have that fall off into something that you don't want it to fall into. So I got a glove so I don't burn myself. I have a polyethylene filler rod, and I'm going to turn the temperature up about halfway. We'll turn this guy on. So that's actually not as loud as I was thinking it was going to be. We're going to give this about a minute for this guy to heat up, and then we'll get to work. Okay, let's see what we got. Now, if I really cared about this piece, I would take a die grinder and I would kind of grind out a little groove in here so that it has more chance for this plastic to actually bond with both sides. So just to play around, I'm just going to push this into that crack. So it's basically going to lay on top of it. Alright, so it is bending, so it is melting. You can see it turning clear. And I'm basically just going to push it down and use the heat to melt it. So I think 5 works, but I'll probably go up a little bit hotter for this application. Alright, I'll pull it up. There we go. So I want to leave the fan running, but I'm going to turn it all the way down to 0. I'm going to let that run for about 5 minutes, and all it's going to do is going to pull the heat out of the tool. Alright, it's been about 5 minutes, and we can see that repair. And I did notice that base material that was fairly close together when I started. It looked kind of like this crack right here. So that was definitely able to melt the base material as well as the plastic I was putting into it. Again, if I really want to make this a good repair, I would groove out that and do a channel so that the filler would have more material to actually stick to. And if I really cared about it, I would even sand that down flat to make it look nice. So overall, that is a very nice tool.